Hi everyone, my name is Hope McGovern. I'm a postgraduate student at the University of Cambridge, and today I'd like to talk to you about my work on a source criticism debiasing method for GloVe embeddings. So first, let's talk about the idea of bias in word embeddings before we get into what methods have been proposed previously to mitigate it and how ours is different. Word embeddings are numerical representations of text that capture semantic relationships between words. This includes models you're probably already familiar with, like GloVe, Word2Vec, and FastText. In this paper, we're only concerned with GloVe, but the method is theoretically agnostic to the underlying embedding model. So we have these models that are learned in an unsupervised way on large public corpora, but the problem is that they consistently exhibit known human social biases. This includes benign biases, like flowers are more pleasant than insects, as well as more problematic ones, like European names are more pleasant than African names. And there's also a concern about gender/occupational bias, as seen with this seminal example from Debiasing. Man is to computer programmer as woman is to X, where the word embedding model supplies traditionally very female-dominated occupations. So let's say you want to mitigate this gender bias in word embeddings. It's not a given as to how you would go about it or what an ideally debiased model should look like. One way that's been proposed might be called hard debiasing. This is from Debiasing et al. This is when you zero out the gender direction for each word vector W in the model. The gender direction would be the vector for he minus the vector for she. This is a post-training debiasing method. Another method proposed by Zhao et al. In 2018 is to use an additional training objective to encourage gendered information to reside in a specific part of the word embedding, and then the word embeddings are simply truncated before using them for inference. And there are a few problems with both of these methods. Golden and Goldberg have pointed out that although these methods appear to remove gender bias, the unwanted associations of gender and occupation still exist. They've just been moved into latent space. Furthermore, I think there's another problem, which is that there are downstream implications of using a model that has had any notion of bias removed from it. And I think that particularly comes into play if you're applying some debiased word embeddings to a new corpus, and that corpus might have gendered words that haven't been directly addressed by one of these debiasing methods. So this is where we get into the idea of source criticism. In the humanities, source criticism is a method of evaluating the contextual lens of an informational source in order to determine its reliability. So this is kind of like if you've been in an English literature class and your teacher said something like, okay, before we read The Adventures of Huckleberry Finn, we need to be aware that the ideas in here about race are problematic. And we're still going to read it, but we need to kind of discount some of the problematic ideas contained herein. And this is essentially the inclusion of explicit bias representation, which is an idea that hasn't been explored much in the literature. It's the notion that if we're made aware of the bias ahead of time, we can discount it when we see it. And if we apply this to word embeddings, we get the idea that an ideal debiased model is not which has no conception of bias, but rather one that is aware of its own bias and therefore can kind of self-correct. However, this approach requires us to know ahead of time which training information or subset causes downstream bias. To do this, we need influence functions. Influence functions make it possible to determine which inputs to a model exert the most influence over model inference at test time. And essentially what influence functions do is that they approximate the result of moving one example at a time from the dataset and then completely retraining the model, which would be computationally intractable on its own, but these make it computationally tractable. And influence functions are especially interesting because they provide insight into model behavior by directly tracking how single training examples can affect downstream inference. So recently, Brunet et al. Have provided an influence function-based fast approximation method to word embeddings as a way of explaining learned bias. We take their method and we show that you can use it to actually mitigate bias instead. So our method happens in two steps. First, with a single pass through the corpus, we use Brunet et al.'s method of approximating differential bias to generate a weighting factor beta for each document. And this weighting factor tells us by how much each document in the corpus contributes to the downstream bias at test time. Then, once we have these weighting factors, we use them to update the word vectors relevant to our bias metric to what they would have been had the bias document been counted as less reliable during training. So according to algorithm 1 that you see on the screen, if the document does not affect downstream bias with respect to some bias metric, then the weighting factor beta becomes 0 and the true co-occurrence matrix is used. If it instead increases bias at test time, the co-occurrence matrix is slightly decreased for the relevant words, and that's scaled by how heavily biased it is downstream. And the third option is that if a document decreases bias downstream, the co-occurrence matrix is slightly increased for the relevant words, which strengthens the co-occurrences of more balanced and gender-balanced terms. So to test this, we train an initial GloVe embedding model on a corpus constructed from a simple English Wikipedia dump using 75-dimensional word embedding vectors. To start with, we test the top 1 analogies test, and that measured about 35%. That's less than the state of the art, but we're just really concerned with proving proof of concept here. We then measure the effect size from 2 different word embedding association or wheat test word sets before and after our mitigation technique. And we observe that our source critical GloVe does actually decrease the effect size, averaged over 10 trials, for both of the test sets that we use. We rerun the built-in top 1 analogy test on the final embedding model, and we find that it similarly achieves 35%. So we think this demonstrates a pleasant proof of concept that we can use explicit knowledge of bias to actually mitigate itself. Finally, for future work, we plan to expand the coverage of the method to debias with respect to multiple metrics at once. It's currently specific just to one particular bias metric at a time. We also will be incorporating robust statistical significance testing across a variety of different embedding pre-training parameters and corpora. And finally, demonstrating that our method is in fact model agnostic by trying to apply this method to other embedding techniques such as word-to-vec and fast text. Here's a quick look at my work cited for this presentation. And with that, I'll say thank you for attending my short talk. Please do reach out to me if you have any questions or want to discuss my work more. And I hope you all enjoy the rest of the conference.